Welcome back. If you've heard about blockchain but aren't quite sure what it is or how it works, you're in the right place. In today's video, we'll be diving deep into the basics of blockchain technology, what it is, how it works, and why it's such a revolutionary concept in the digital age. So let's kick things off with a fundamental question. What exactly is blockchain technology? At its core, blockchain is a decentralized, distributed ledger that records transactions across multiple computers. The record cannot be altered retroactively without the alteration of all subsequent blocks and the consensus of the network. Sounds complicated. Don't worry, we're going to break it down into simpler terms. Imagine a traditional ledger, a book where all financial transactions are recorded. This ledger is kept by central authority, like a bank. Now imagine instead of just one central authority holding that ledger, copies of the ledger are distributed across thousands of computers worldwide. Each time a transaction is made, all copies of the ledger are updated simultaneously. This is, in essence, what blockchain technology does, but with added layers of security and transparency. To understand blockchain, you need to understand two key components: blocks and the chain. A block is a collection of data, and in the context of blockchain, it contains three main elements. Data. This is the information being recorded, such as a transaction. In the case of Bitcoin, who sent what amount to whom? Hash. A unique identifier for each block. Think of it as a fingerprint that distinguishes one block from another. Once a block is created, its hash is generated based on its data. Hash of the previous block. This is what links one block to the previous one, creating the chain in blockchain. This hash ensures that blocks are connected in chronological order and cannot be tampered with. Let's take a closer look at how a block is created. Suppose person A wants to send some cryptocurrency to person B. This transaction is grouped with other transactions to form a block. Once this block is created, it's broadcast to the network of computers, also known as nodes. These nodes then verify the transactions in the block through a process called mining. Mining is a critical process in blockchain technology, especially in the context of cryptocurrencies like Bitcoin. It involves solving complex mathematical problems to validate transactions and add them to the blockchain. The first node to solve the problem gets to add the block to the chain and is rewarded with cryptocurrency. This process not only secures the network, but also ensures that all transactions are legitimate and follow the network's rules. One of the most powerful features of blockchain technology is its immutability. Once a block is added to the blockchain, it's nearly impossible to alter the information within that block. If someone tries to change the data in a block, the hash of that block will change, which will also change the hash of the next block in the chain, and so on. This would require an immense amount of computing power to change all subsequent blocks, making tampering with the blockchain practically infeasible. Another fundamental aspect of blockchain is its decentralization. Unlike traditional systems where a central authority controls the data, blockchain is maintained by a network of nodes, each with a copy of the entire blockchain. This means that no single entity has control over the entire network, reducing the risk of manipulation, fraud, or censorship. But how do all these nodes agree on which transactions are valid and which are not? This is where the consensus mechanism comes into play. A consensus mechanism is a set of rules and protocols that nodes in the blockchain network follow to achieve agreement on the state of the ledger. There are several types of consensus mechanisms, but the two most common are proof of work and proof of stake. Proof of work is the mechanism used by Bitcoin. It requires nodes to solve complex mathematical puzzles to validate transactions and add them to the blockchain. The first one to solve the puzzle gets to add the block and is rewarded with cryptocurrency. However, proof of work is energy intensive, as it requires significant computational power. Proof of stake, on the other hand, selects the validator of the next block based on the amount of cryptocurrency they hold and are willing to stake as collateral. The more you stake, the higher your chances of being selected to add the next block. Proof of stake is considered more energy efficient compared to proof of work. Now, let's talk about one of the most exciting applications of blockchain technology, called smart contracts. A smart contract is a self-executing contract where the terms of the agreement are directly written into lines of code. These contracts automatically execute and enforce themselves when the specified conditions are met, without the need for intermediaries. Beyond cryptocurrencies, blockchain technology has a wide range of applications across various industries. Here are a few examples. Supply chain management. Blockchain can be used to track the origin and movement of goods in a supply chain, ensuring transparency and reducing fraud. For instance, a coffee company could use blockchain to track the journey of coffee beans from the farm to your cup. Healthcare. Blockchain can securely store patient records, ensuring that only authorized individuals can access them. This could also facilitate the secure sharing of medical data between different healthcare providers. Real estate. Blockchain can streamline property transactions by providing a secure and transparent way to record property ownership and transfer deeds. This could reduce the need for intermediaries like title companies and speed up the process. Digital identity. Blockchain can be used to create secure, decentralized digital identities that give individuals control over their personal information. This could be used for anything from online authentication to reducing identity theft. While blockchain technology has enormous potential, it's not without its challenges and limitations. Here are a few to consider. Scalability. As the number of transactions increases, some blockchains can struggle to process them quickly. This is known as the scalability issue. Solutions like sharding and layer 2 protocols are being developed to address this, but it remains a challenge. Energy consumption. Especially with proof-of-work-based blockchains, the energy consumption required for mining can be substantial. This has raised environmental concerns and has led to the development of more energy-efficient consensus mechanisms like proof-of-stake. Regulation. The regulatory environment for blockchain technology and cryptocurrencies is still evolving. Different countries have different approaches to regulation, which can create uncertainty for businesses and individuals involved in the space. Interoperability. There are many different blockchains, but they don't always work together seamlessly. Interoperability between blockchains is a challenge that needs to be addressed to realize the full potential of the technology. User experience. For mainstream adoption, blockchain technology needs to become more user-friendly. The process of setting up wallets, managing private keys, and conducting transactions can be complex for non-technical users. So what does the future hold for blockchain technology? The possibilities are endless. As the technology matures, we're likely to see increased adoption across various sectors. Governments may begin to integrate blockchain into their operations, industries might standardize blockchain protocols for efficiency, and new innovations like decentralized finance, DeFi, and non-fungible tokens, NFTs, will continue to evolve. To sum it all up, blockchain technology is a decentralized, secure, and transparent way to record transactions and track assets in a digital space. It's the backbone of cryptocurrencies like Bitcoin and Ethereum, but its applications go far beyond that, with the potential to transform industries from supply chain management to healthcare. While there are challenges to overcome, the potential benefits of blockchain technology are too significant to ignore. As we move forward, understanding the basics of blockchain will be crucial, not just for tech enthusiasts, but for everyone who interacts with digital systems. Thank you for joining us today. If you found this video helpful, make sure to hit the like button and subscribe to our channel for more in-depth explanations and tutorials on blockchain, cryptocurrencies, and trading strategies. Have any questions or topics you'd like us to cover? Drop them in the comments below. Until next time, stay informed and trade wisely.